Is it visible now?
Yes, sir.
Okay. So till last session, we have completed modeling of the base slab, modeling of the vertical walls, and modeling of the central column. So the central column is still open from top, so we have to place a one cover on that. Correct. So we just add one vertical wall. So maybe we need to add one slab on that. So for that, what we need to do? So I will just go to the top view. Will copy some plates. Basically, I will just copy bottom plate and I will paste it on the top of that central column. So I'm just some of the plates are not come. Okay. Or I can do a new slab on top of that wall also. Central column highlight. I just want to know the radius. Okay. For that, I will select this one 0.235 or better way, I will directly go to that central base plate only. That will be much quicker and easier. Why some of the plates are not? Now go to, so we want to copy this first circle. For that, what I will do, I think we are in the internal diameter of the central wall is not correct. I think Let me check dimension. Yes, that's why 0.471, I guess. 0.471. Yeah, that's why it's shown as a very small. Okay, no problem. We will delete all these plates. By mistake, instead of radius, we added as a diameter. That's why it was happen. Okay, no problem. We will add a new internal central column. I'm going to the run structural wizard, surface model 4.1. Now add radius. Last time what happened? We divided it 471 divided by 2. So that's why it was by mistake. We just considered half radius. Now, yes, now it is coming properly. Now we will just copy. We have to select only this part. So for that, select inverse. Now I will copy this only base plate. Copy, paste 4.1. Create one more group as a cap. Just check whether it is yes. But now we need to assign central column because it is not selected or we have previously deleted. So I will assign those. I will just select walls, select inverse, So now this vertical pillar can be easily get selected. Central column, yes. Now it is assigned. Save. Just make all model is visible. Save. Okay. So now after this, we have to prepare or we have to add laundry channel. So that is this laundry channel. So we need to add this. So at what height we need to add this? So maybe just go to the section, take what is the height from top. Okay. 127.35 minus 126.55. So from top, it will start at zero point 0.8 meter. Okay. And what is the width, clear width? It's not visible. Yes, the clear width is 600 and wall thickness is 0.15. Okay, so zero point 0.1 plus zero point 0.6 plus point not 75. So total width of the launder channel will be zero point 0.1 plus zero point 0.6 plus point not 75. So 775. So can we need to provide a clear width, center to center width of the launder channel is 0.775. Okay, at zero point 0.8 meter from the top. Just open your walls only. We don't need any other things. Just take a judgment where we can provide the launder. 0.82. Yes, this can be a good place. Instead of zero point 0.8, we can provide launder at 0.82. So some small adjustment can be possible. And if you want to be very precise, so you need to divide or you need to create your plate such a way that at from top your node should be at 0.82, but it's fine. So instead of zero point 0.8, if you are getting 0.82 or 0.75, it's totally fine. In if you consider results, so there will not be any drastic change or this. Because of this there will be very minor effect, and that can be absolutely neglected. Okay, so we can provide from our laundry channel at 0.82. Okay, so now how to add that? Okay, so again, just open all entire geometry, go to the beam cursor, select all. You have already created beams there. Okay, so just now we have only beams are visible. So these are our the first beam, correct? So you can delete this because we have already created two. So these are our two beams. So those two beams can be copied to 4.1 at top. 4.1. I'm just want to paste those node at 4.1. After that, I will again move it down to 0.82 from top. Okay. Now, yes, you can see this. I got this at 4.2. So what I will do, I will just select these two beams. and copy that to this node. I will select this beam, copy to. Okay. Now again, I will select. Yes, I want to save this. Okay. Now again, I want to copy this beam with reference point, the last point, creating some geometry again. Reference point, last point. Okay. So now I'm going to plan view here. I will keep only beams visible. I don't require all the beams at the base because it's now the construction step by using that beam is now over. So I can delete those beams. Yes, I don't require now those beams. Okay, now I'm going to plan view. These are the two beams. Just check what is the dimension. Oops. Our width of the rounder is 0.775. So what I will do, I will copy this again, copy a reference point. Same thing with this, copy a reference point. Okay, now I will check. So I will merge these beams as a single beam, merge selected member. Okay, same thing with this also, merge selected member. Okay, so now I will insert a node at 0.775. Insert, I will select this beam also, 0.775. Okay, so this beam I can delete. Now just check, it make us a round figure. That's why 0.78 we are getting. Okay, so you can delete this beam also. So it can delete this also. Now go to the plan view, or no, select 4 node, create one plate. So this is too big. So what you can do, just select this and right click and generate plate mesh. So 0.4 it's okay, only one segment. Maybe you can go with 2, 1, 2. Now you have two plates for the lounder slab. Again, now select these two plates, go to the circular repeat command, Y axis of rotation, that is okay. Node, that is first node, or maybe you can select that 00. I'm just putting node number 198. what happened? Error. Can you see this? So entire nodes are clearly matching. So you can see this. Can you follow my cursor? So this is the Launder slab which is connected to the wall, which is perfectly matching with the slab. Okay, save.
सर एक बार आप बताइए तो
कौन सा?
ये लॉन्डर वाला सर।
ये पूरा स्टेप?
हाँ सर।
मैंने क्या किया इसमें कंस्ट्रक्शन लाइंस की है, ठीक है।
यस सर।
तो लाउंडर की विड्थ कितनी थी? वो लाउंडर की विड्थ है, मैंने कैसे कैलकुलेट की, वी नीड टू फाइंड आउट द सेंटर टू सेंटर विड्थ ऑफ द लाउंडर। सो वॉल थिकनेस इज 200, सो हाफ वॉल थिकनेस कितनी होगी? 100
100
प्लस 600 और ये
700
700 और ये 150 की हाफ थिकनेस कितनी होगी?
सर 0.75।
हाँ, तो इसका टोटल हो गया 775। So that's why what I did, I copy some of the beams from bottom
सर वो
at
8.2 लिए आप, वो कहाँ पर डिस्टेंस कैसे आया वो?
हाँ वो
वो
डिस्टेंस।
फिर उसके बाद आपने लॉन्डो कॉपी किया तो वहाँ तो कंफ्यूजन हो गया था, इसलिए बीच में नहीं डिस्टर्ब किया कि आपको दिक्कत हो जाएगी।
नहीं ठीक है ना, मैं बताता हूँ। हम 0.82 कैसे लिया, दैट इज द क्वेश्चन। सो ये दिस इज द बेस स्लैब ऑफ द लाउंडर, करेक्ट। लाउंडर हमारा यहाँ पे आ रहा है। सो
यस सर।
व्हाट इज द हाइट फ्रॉम टॉप, कितना है इसका डिस्टेंस? तो इफ आई गेट कैलकुलेटेड 127.35 माइनस 126.55, ओके,
ओके
तो कितना आता है? सो डिफरेंस इज 0.8। सो व्हाट वी नीड टू प्रोवाइड, लाउंडर स्लैब शुड बी एट 0.8 फ्रॉम द टॉप।
ओके
ओके, तो मैंने मेरे स्टैट में चेक किया तो मेरे आई हैव द नोड विच इज द क्लोज टू 0.8 इज 0.82, एग्जैक्ट मेरा 0.8 पे नहीं है, ठीक
ओके।
है। तो इंस्टेड ऑफ 0.8 मैंने क्या किया, 0.82 को सिलेक्ट किया और मैंने वहां पे लाउंडर डाल दिया।
वो लॉन्डा कैसे डाले सर, एक बार बता दीजिए।
वो लाउंडर मैंने क्या किया, मैंने जो बेस स्लैब का था ना, ये बीम्स मैंने कंस्ट्रक्शन किया था,
हम्म,
वो सेम टो, आपको टो पता चला कैसे किया टो?
ये सिलेंड्रिकल प्लेट वाला पता चला सर, वहां पर थोड़ा कंफ्यूजन नहीं आप समझ में आया था।
नहीं नहीं नहीं, टो टो, ये टो कैसा किया, सेम है वैसे।
हाँ ये टू समझ में आया था।
तो
वो
सेम है ना।
वो उसको कॉपी करके रेफरेंस पॉइंट पर जाके फिर क्लिक किया, जितना डिस्टेंस पे उतना डिस्टेंस किया।
हाँ तो सेम वैसे ही है, ये भी कुछ गलत, बाकी कुछ डिफरेंस नहीं है। यहाँ पे इंस्टेड ऑफ 0 0 हमने यहाँ पे ऊपर उठाया है इसको, एक्सेप्ट दैट एवरीथिंग इज सेम। आप एक फिर से बार कल एक काम करिए, रिकॉर्डिंग देखिए, अगर आपको नहीं आता है, समझ में आता तो मैं डेफिनेटली आई विल हेल्प यू, ठीक है।
सर एक चीज आप पूछा था,
हम्म।
मैं उसमें रेक्टेंगुलर टैंक में,
हम्म।
तो आपने जो एनालिसिस किया था मैक्सिमम 8 पॉइंट समथिंग आ रहा था आपका, लेकिन मैं जब एनालिसिस कर रहा था तो वो कम आ रहा था सर। तो उससे कोई दिक्कत नहीं ना है, मतलब 13 से 22 से बिलो आ रहा था।
नहीं, मैं ऐसा विदाउट आपका मॉडल देखे ऐसा कुछ नहीं बोल सकता।
और उसमें इसमें ये भी चीज हो रहा था कि आपने फुल टैंक पर देख रहा था, लेकिन मेरा स्टैट इम्पेटी टैंक एम्पेटी था, तो फिर वो ले रहा था।
नहीं नहीं, आई नीड टू चेक, ऐसे डायरेक्ट मैं नहीं बता सकता कि वो ठीक है नहीं या नहीं ठीक है, क्योंकि पूरा सब चेक करना पड़ेगा ना, लोडिंग करेक्ट है नहीं है, क्या लोड की इसकी लोड केसेस उसमें ऐड की है, करेक्ट।
आप ही वाला सेम था सर, लेकिन थोड़ा सा मिस्टेक हो रहा था, इसलिए मैं
नहीं
पूछ।
ठीक है ना, स्टार्ट में हो सकता है, नो प्रॉब्लम। तो वो एक बार देखना पड़ेगा, ऐसे विदाउट मैं देखे हुए ना ऐसा नहीं बोल सकता ना कि वो ठीक है या सही है या गलत है। एंड वन थिंग इज इट्स लाइक दिस इज अ डिजाइन. सो मैथमेटिक्स में कैसे होता है कि 2 + 2 = 4 होता है. हम्म.
यस सर।
तो डिजाइन में ऐसा नहीं होता कि दिस इज जजमेंट. हाँ, अप टू सर्टेन एक्सटेंट यस. सो आवर मेन इंटेंशन इज आवर स्ट्रक्चर शुड बी सेफ. वो किसी भी हाल में फेल नहीं होना चाहिए. तो मे बी यू कैन गो विद 12 mm बार, someone is go with the 10 mm bar, unless until it is safe, so everything is good. तो ऐसा वो 2 + 2 = 4 वाला नहीं है, थोड़ा सा ऊपर नीचे चलता है. मेरा अगर 45 आया, आपका 43 आ रहा है, आपका 48 आ रहा है, दैट इज ओके.
नहीं सर, डिफरेंस तो था मेरे में, इसलिए मैं
नहीं हो सकता है ना कि कैसे मॉडल किया है, क्या है लोड कॉम्बिनेशंस, क्या लिया है, क्या लोड लगाया है, वॉल की हाइट क्या है, वो सब थोड़ा सा देखना पड़ेगा. ऐसे मैं विदाउट सेइंग एनीथिंग आई कैन नॉट कमेंट एनीथिंग
ठीक
कि
है
वो
सर।
सही है या गलत है.
क्लास के बाद देख आप शेयर करता हूँ मैं स्क्रीन।
और
हाँ.
जो आपका जो मॉडल था सर, उसमें
हाँ,
वो ओपनिंग भी था ना, उसके कारण हमारा मॉडल और आपका मॉडल वो भी फर्क हो सकता है शायद
हाँ,
रिजल्ट
हो
में।
सकता है, हो सकता है. ओपनिंग के कारण क्या हो सकता है कि अराउंड द ओपनिंग देयर विल बी सम स्ट्रेस कंसंट्रेशन.
यस
पहले
यस
वहां पे स्ट्रेस नहीं होते. अगर आपने ओपनिंग दिया तो कहाँ क्या होता है कि वहां पे स्ट्रेस कंसंट्रेशन ज्यादा होता है, तो वहां पे सब थोड़ी बेंडिंग मोमेंट वगैरह वगैरह थोड़ी सी ज्यादा आती है.
ओपनिंग दिया तो एरर बता दिया, तो मैंने फिर से बैक गया, फिर मैं मॉडल 2-3 बार बनाया, लेकिन मेरा नहीं आ रहा था। फिर मैंने पूछा अब नहीं होगा मुझसे, तो मैं इसलिए मैं पूछा कि नहीं सर से पूछना उचित होगा, मैं किया, नहीं हुआ मुझसे।
नहीं ठीक है ना, आप मुझे एक बार मॉडल भेज दीजिए ईमेल पे, तो मैं एक बार चेक कर लेता हूँ. ठीक है.
सर क्लास में पॉसिबल नहीं है?
नहीं, मुझे मुझे नंबर ऑफ क्लासेस अलॉट किए, उसमें मुझे सब फिनिश करना है.
तो फिर सर वो डाउट मेरा कैसे क्लियर होगा कि ये चीज तो क्लास
हम दोनों अलग से बात करते हैं ना, उसमें कोई प्रॉब्लम नहीं है.
ओके सर,
ठीक है.
ओके सर।
तो सैटरडे संडे कभी भी आप मुझे कॉल कर सकते हैं, हम स्क्रीन शेयर कर सकते हैं, आप दिखाइए मुझे क्या प्रॉब्लम है. डेफिनेटली यस, वी आर देयर टू हेल्प यू.
ओके सर।
ठीक है. तो ये यहाँ पे लाउंडर हो गया, आपका लाउंडर का क्लियर हो गया.
अब सर क्लास देखते ही पढ़ूंगा, अब ऐसे नहीं होगा
हाँ.
फिर।
हाँ ठीक है, एक बार आप फिर से एक वीडियो देखिए, कैसा क्या किया, क्या क्या स्टेप्स मैंने फॉलो किए. सिंपल है. मैंने यहाँ पे एट फ्रॉम टॉप 8.2 पे मैंने बीम्स कॉपी किए, उसका एक्सटेंशन बाहर निकाला 0.775 को, उसमें से एक प्लेट क्रिएट किया. वो प्लेट काफी बड़ा आ रहा था, इसलिए मैंने उसको ब्रेक किया 2 प्लेट में, और वो 2 प्लेट सिलेक्ट करके मैंने उसको सर्कुलर रिपीट कमांड देके पूरा अभी मैंने उसको
हाँ वो तो
वॉल, हाँ वॉल बताया मैंने उसको, अपना लाउंडर स्लैब हो गया. ठीक है. अभी व्हाट वी नीड टू डू, वी हैव टू ऐड द लाउंडर वॉल्स, दिस वन. ओके, ये वॉल हमको ऐड करनी है. ठीक है. तो उसका अपने को ये देखना पड़ेगा, बीम्स है क्या इसमें.
डेप्थ ऑफ द लॉन्डर वहां पे भी हम नीचे का थिकनेस भी हाफ ले सकते थे क्या?
नहीं, थिकनेस भी आप हाफ ले सकते हो, लेकिन बेटर फॉर एलिवेशन मे बी वी विल जस्ट कंसिडर ओनली द ये एलिवेशन.
इंटरनल।
हाँ, इंटरनल. सो इट विल बी फॉर कैलकुलेशन पर्पस, इट विल बी इजी.
ओके ओके।
ओके. अभी हमको ये वॉल ऐड करनी है. ठीक है. ये अपने पास ये बीम्स है, 2 बीम्स. I just open that beams because I want to find the node, means distance. What is the distance of that? So x is 7.375. Okay, from 0. So I will write it down somewhere. X is equal to 7.375. This is our radius. Correct?
यस सर।
ये मेरा लाउंडर का, इसका भी वही होगा. माइनर थोड़ा सा फर्क हो सकता है. 7.37. फिर से एक बार I will add one group for Launder, so it will be very easy. Launder slab, wall, highlight, select inverse, central column I don't want because it will be come in between for selection. Just go to the front view. So these are your Launder slab plate. Select all these plates. Associate. Okay, now just keep this on. I will just check again. Then the radius 0.7375. Okay, fine. And also check the Z axis or Y 3.280. So you write that also 3.280. Okay. So now I'm going to run structural wizard. I'm going to plate surface model, cylindrical surface, length 0.8 because we are from top at 0.82 meter. Start radius that is 7.375. Correct. 7.375. Avinash ji, hope
यस सर,
correct है ना?
यस सर,
Okay.
आप गलत थोड़ी पढ़ाइएगा सर।
नहीं ऐसा नहीं। मतलब मेरा इंटेंशन था कि समझ में आ रहा है ना?
हाँ सर, वो आ रहा है।
बस वही। तो
नहीं आएगा
0.8
तो मैं बीच में बोल दूंगा।
हाँ हाँ कभी भी एनी टाइम नो प्रॉब्लम। अपनी बॉल की हाइट कितनी है 0.8 ओके तो 0.8 को मैं डिवाइड कर रहा हूँ अपने वॉल थिकनेस है 150 0.8 डिवाइडेड बाय 0.15 तो आ रहा है ऑलमोस्ट 5 ठीक है इसलिए मैंने इसको I will create a division along length as a 5 and division along periphery that is a fix we cannot change that is a 98 okay 1 0 apply okay now check the unit we already in meter so I'm not checking last time I am not checked because I'm confident that it's in meter but better to check now I'm going to merge this with my stat okay yes so now I'm getting this dialog box so where to put this so x0 that is fine z0 that is fine but I need to put the values of y because our Launder wall be at some distance from the base okay and what is that so we already noted that my y coordinate is 3.280 okay
Yes, sir.
yes duplicate nodes ignored so means it is perfectly match so just check the isometric view now you can see the Launder walls are attached to the Launder slab okay so now create a group again immediately so after that for selection it will be quite easy Launder wall okay select Launder slab highlight go to select inverse plate new view now we have only Launder wall Select all plates, associate. Done.
Yes, sir.
Okay, so almost our model is ready. So if you only one thing is missing, that if you go to the top view, roof plan, something like that, you can see some openings in the main wall. From that wall, water can be get pass. Okay. सो लाउंडर में पानी जाना चाहिए ना, तो कहाँ से जाएगा? अभी आपने देखा तो पानी जाने के लिए जगह है क्या? नहीं है. Is there any space?
No, sir.
So what we need to do? So we need to provide some opening so that at this location water can get passed to the laundry channel. So simple है. ये थोड़ा सा चेक कर लो कितना आता है, तो अप्रोक्सीमेटली भी डाल दिया तो ओपनिंग्स डाला तो भी चलेगा. यहाँ पे ड्राइंग में दिया होगा कि देखो, if I go to opening, there will be some thing is mentioned. यहाँ से भी आपको इसका साइज पता चल सकता है. रूफ प्लान में दिया होगा. I have seen somewhere. Yes, you can see this, the elevation 127, and what is the elevation of this? So from that we can calculate the depth. Okay, no problem. So can you see this line which represent this point? So maybe I'm not sure, but the one dimension is missing here. But we can delete one plate so water can be get passed through this. This line, this line. The elevation of this line is missing, but okay. If I go to the slab roof plan, maybe approximately okay, let's count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 openings can be create in our STAD. How to create? Just go to the, just keep open central. I don't want this central pillar. So inverse plate. I don't want that cap also. Now I will just keep these walls are open. Okay, select our wall, internal wall. Just go to the front view. Just select on the bottom row. Okay, now approximately you can delete 1, 2. I'll just show some representative. I will not just select all the 13, but I will just show 1, 2, maybe this one. Delete maybe this one. 3, 4. So like you can delete some 13 plates. डिलीट करना कोई मुश्किल बात नहीं. 1, 2, 3, 4, 5, 6, maybe 7. ठीक है, मैंने अभी 9 डिलीट की है. So same, it will be reflect to this side also. So basically what we need to do, so ideally we are providing some space. In reality हमें इसमें कुछ पानी डालना है क्या? नहीं डालना है. हमें उसमें कुछ पानी नहीं डाला तो अंदर जाएगा क्या? नहीं. But just for representation we are just deleting some plate to match overall geometry. Got it? If you can see this, we have created some openings. It is visible like this.
Yes, sir.
Yes,
Okay.
sir.
Okay. ठीक है. So आपको यहाँ पे भी इसको रिपीट करना है. जहाँ पे जैसे ओपनिंग्स है, टोटल नंबर्स ऑफ ओपनिंग्स है, based on that you can delete some plates. So क्या हो गया कि because of that wall little bit there will be some little bit some stress concentration around that opening. So we have to just take care of that. Otherwise, yes, because it's at top, so it is always very less subjected to the water pressure. Okay,
Okay, sir.
done. हमने ये भी किया, आपने already सब done है. So next step, what will be next step? We have to apply the support. For that, again, we need to add one more group, entire base slab. Okay. So just select all these horizontal plates at bottom. Yes, create one more group. Base slab. Associate. Done. Now next step will be support. Go to the support page, create foundation, plate mat, Y, same assumptions, 17,500, add. Select that support, select base slab group, highlight, assign. Now all the supports are now assigned to the base slab. Okay, save, select beams because we don't want any beams in our model. Delete. Okay, now we are conducting different checks. Tools, check multiple structure. One, that is okay. Duplicate nodes. No duplicate nodes. Duplicate plates अगर है तो चेक करो. No duplicate plates. That's good. Orphan nodes directly remove अगर है तो remove करेंगे. Zero length member beam अगर कुछ है तो no. Wrap plate यहाँ पे अपने को मिल सकते हैं because क्या हुए at the origin we have some uh, plates which is having aspect ratio is critical or maybe क्योंकि अगर हमने बेस स्लैब को मैंने ओपन किया if I just keep open base slab I don't want to see the support. Save, yes. So at the center you can see if I selected one plate, this is my one plate which is triangular. So if I check its dimension, what is the width? 0.03 meter and as against length of that plate is 0.47. So because of that, this is not, STAAD is saying that it is aspect ratio for this plate is not good. So that will just only warning. So we can ignore that. Because of that, if we see wrap plate, so we will have some numbers there. Okay. So go to the tools. So select all the plates here and check no overlap plates. That's good. Check overlapping plates. If plates are not connecting each other at node, so it will check there. But because of that, definitely we will get some warnings, so we can ignore that. Okay. So now we need to assign the properties. Okay. Go to member properties page, thickness. 0.2 is our wall thickness. Sorry. 0.5 is our base slab thickness. Okay. 0.15 is our lounder wall thickness. I don't remember what is the lounder slab thickness. 150. Same. Okay. Now we have to assign this. And I think 200 for the central pillar also. 200. Okay. Done. So only three material properties that we need. So this is 200. So select walls, assign, select central column, highlight, assign. Okay. Maybe cap, that can be also 200 mm. Assign. Now base slab, highlight, 0.5. I just want to make sure. Base slab, assign. Okay. Now this is 150. So we can assign to the lounder slab. Assign lounder wall. Highlight. Assign. Okay. Close. Save. Just check again from missing attributes. Missing property. Yes, still there are some properties which is having no assignment for the. So this is cap plate. Go to the material, highlight, select this one, highlight, assign. Okay, save. After that, again, we will just check again from missing properties. No entry with missing properties, missing attributes, missing elasticity. So all good. So this way we have done our different checks. Now what is the next step? Next step is we have to assign the
Load.
loads. So go to the loads as usual, add dead load D, live load L, fluid load F, soil load H, uplift okay. Now add load combinations. Start with 100. D plus live plus D plus live plus fluid tank full condition. Correct? Service level. That's why I'm not adding any factor. Okay. 101 tank empty case. बोलिए.
जो लोड कंडीशन रेक्टेंगुलर टैंक लगा था सेम इसी में भी लगेगा ना.
हाँ, लोड कॉम्बिनेशन का क्या इरिस्पेक्टिव है ना, उसको चाहे रेक्टेंगुलर हो या ट्रायंगुलर हो या लोड कॉम्बिनेशन तो हर एक पे वही होगा ना.
Okay.
अब ये टैंक एम्प्टी, दिस इज टैंक एम्प्टी, डेट प्लस लाइव ऑलवेज देयर प्लस एच रहेगा. ठीक है. 102 D plus uplift. Now I will start with the factor load combination. 1.4 D plus 1.6 L plus 1.4 F tank full condition. Avinaji, can you please mute?
Sorry sir.
No problem. So I'm just adding the factors 1.4, 1.6, 1.4. Tank full condition with factored load case. Okay. Now I will consider as a tank empty factored 102 1.4 D plus 1.6 L plus 1.6 6H. I'm not adding fluid load. D plus L plus H, 1.4, 1.6, 1.6. Now uplift 0.9 D plus 1.2 lift. Okay, so now our load combinations are also done. So we will quickly apply loads, dead load, add self weight -1. Okay, it is automatically added. Live load. Okay, live load. Can you tell me where live load will be there? Where we can consider live load. Any thoughts on this? हम इस पे लाइव लोड कहाँ पे लगा सकते हैं?
At the base.
Base पे is it worth to apply live load on the base?
On the truss,
On the
truss,
truss. Where is truss?
that rotating shaft.
Yes, but again it will be get
It is
transferred.
transferred on the central portion. Central
Yes,
slab
correct.
top central portion.
Yes, 50% will be get transferred to the central shaft, and some of the 50% will be get transferred to the wall.
Yes.
Correct. You are absolutely correct. And in addition to that, we have this laundry channel. Suppose if laundry channel is
Deterrence.
covered with the grating or some kind of the covered material, so we need to consider entire this portion, the top of this launder, that can be subjected to the live load. Okay,
Yes.
so we need to apply that live load on this launder channel. तो क्या होगा कि if you see this L shaped wall is act as a cantilever. Okay, and suppose, can you see this? This
Yes, sir.
this is some kind of the grating. So one person can be stand over here, and that live load can be get transfer. 50% load will get transferred to the wall, and 50% load will be get transferred to the main wall of the
Inner wall.
tank. Why I'm 50% consider? If it is uniformly, if it is concentric load, so definitely reaction will be get transfer. But what we are assuming, so we are assuming 3 kilonewton uniformly live load, so it 50% half. Maybe I will add some sketch for this. Print screen. Okay, so now what happened? We have UDL over here, correct? So half of the load will get transferred to this wall, and half of the load will get transferred to this wall. Agree? This is UDL.
Yes, sir.
3 kilonewton per meter square, or 3 kilonewton per meter. So what is the span? The span is
0.775.
0.775. So what will be the reaction if UDL is 3 kilonewton per meter? It's very simple, easy. 1 point.
1.1.
Correct.
1.
Absolutely correct. So reaction will be 1.16. So say 1.2. Is it okay? So यहाँ पे
Yes.
1.2 की रिएक्शन आएगी, यहाँ पे 1.2 की रिएक्शन आएगी. ठीक है. सो ये तो सब जगह पे आएगा ऐसा. तो what we need to do? So and look, this is what we call as a, this is kilonewton per meter. Means if I draw, this is my span 0.775, and what is the width? That is 1 meter. Correct. So what we have calculated, 3 kilonewton is acting per meter, per 1 meter strip. And what is the span? 0.775. Understand what I want to say?
Yes, sir.
Okay. So this is for 1 meter. That load, this reaction 1.2 meter that we are getting for 1 meter. But again, if we go in our stat and if we check what is the center to center or what is the distance between two nodes, point 0.47. So if I divide this 0.47, okay. So how many parts that can be accommodate? Say roughly 1 meter by 0.47, somewhere 2.12. Okay. Got it what I want to say?
Yes, sir.
This is, so 2. I will create a 2.47, or maybe this is not correct.
On the center.
Only center. Correct. So if I create only one node here, one node here, so this is 0.47. This is 0.47. Okay. Let's say assume 1 meter. And this is our span 0.775. And what for this entire 1 meter, what reaction we are getting? That is 1.2 meter. Okay. So for that, what we can do? We can distribute this 1.2 reaction at 3 nodes, at this, at this, at this. Correct? Agree?
Yes, sir.
Okay. So what I will do? I will divide it by this 3.
Yes, sir. 3.4.
1.2 divided by 3.4 kilonewton. Okay, because it's a reaction. So now I will get the point load, nodal load minus 0.4. Add. Okay, how to apply? Just go to front view, go to your groups, hide this cap plate, hide, highlight, select inverse plate, new view, hide this central column, highlight, select inverse plate selection. Okay, now just select this entire some top portion of the plates for both lounder and internal wall. Okay, now go to the front view, select nodes and select only top row. Can you see this? What I selected? I have selected only top row of main wall and top nodes of the Launder wall. I select this 0.4 Newton, assign to selected nodes, assign. Is it okay?
Yes, sir.
So these are some manual calculation that we need to do manually, calculate the loads and apply it to the your STAD model. And remember, what we have did this entire calculation that should be come in your design report. Okay, so everything how you calculated, so that should be come into your design report. So when you are when you create entire design report, so the person who is checking your calculation, he can understand from where. Means understand means he should cross verify whether it is all the loads are applied correctly or not, if you have missed anything or if you have added overload. So that can be things can be get checked through your design calculations. Okay, so now we have applied the live load, and addition to that, what we need to do, we need to add live load from the bridge also. Okay, from that
Yes.
bridge, but and that self weight also needs to be considered of that the bridge. Okay, so how to add that? Okay, I will just keep, or no, we will finish that also. Clarifier. So this is the bridge, and we need to consider its dead weight. So from where we can get this? So we need to contact process mechanical engineer or whatever, which is the concerned department, and we need to ask. So hey guys, please give me the weight of this bridge. Okay, so it but obvious. So you cannot assume anything. So once you have approached them, you will get something in terms of the loading. Okay. So if I go to, this is the my Excel sheet, which is created for this design of, maybe you can consider as a circular tank or clarifier. So I will just go to the load. Where
सर
it
ये
is
आपके के लिए डिजाइन किया जाता है सर?
क्या क्या?
आपके के लिए डिजाइन किया जाता है ये?
हाँ, if it is in seismic zone, definitely we have to consider the earthquake forces also,
Okay.
because earthquake loads are also predominant loads at some time. So you cannot neglect those. Yes. So can you see this? Clarif walkway bridge. Okay. So what is the walkway? So in my case, my bridge span is 6.50. I think this is the same thing. We have internal diameter 13.2 divided by 2, 6.6. So in this case, we have 6.5. Okay. So bridge and mixing equipment weight. I'm getting the weight of that bridge and equipment is 49 kilonewton. Okay. And what is state going to give this some information? Number of nodes supporting to bridge instead. Okay. So again, if I go back to my, this is a central pier and this is a wall. And okay, so this is the bridge, let's say. So connection of this with the central pier and the wall with 4 nodes. So let's say we have some bolts are getting fixed. So through that bolt, all the load will get transferred, correct? You don't need to worry about that how it fix. So we have to just make that surface, and you have to ask what is the uh, arrangement, how to fix. So whether it is a flat plate, so I can consider uniform load condition on the central pier or center wall. So now what I'm assuming, I have assuming there is 4 noded connection. So I have to consider 4 noded load which will be transfer. Okay, here and at this location. So how we can just check number of loads supporting the bridge instead 4. So load per node कितना आ रहा है? Straight forward 49 kilonewton divided by 4, that is 12.25. Okay, load per node. So I can apply that load in my stride as a 12.25 kilonewton. Okay.
Sir, it should be 8 nodes, no, actually.
यहाँ पे 2 है और यहाँ पे 2 है, ऐसे किया है 4 टोटल नोड. यहाँ पे अगर ये 4 होता है तो 8 होने चाहिए. मेरे केस में 2 है.
Okay.
यहाँ
Okay.
पे 2 है, यहाँ पे 2 है. That's why it comes to the 4 nodes. Okay.
Yes. Yes, sir.
So what I can do, I can add dead load because it's a dead load, correct? Add dead load as a floor load. Sorry, nodal load as a 12.25 minus 12.25. Okay. Now the interesting part. So if I go to this, so these are the fix, correct? Whether it is at this location, but this position will be get changed. Okay, correct, na? If I draw, this is my central pier. At some time, my bridge will be here. So this position will be fixed at all time, correct? But this will be get changed. Sometime it will be here, sometime it will be here. So what we need to do for the worst condition, we need to apply this 12.25 loads to everywhere for outer wall. Okay, we cannot just apply at a one location, maybe at here, but we don't know, we never know. So just for safer side, apply this nodal loads to everywhere outer and apply this 2 nodes here only. Okay, at center part. So that can be okay. Got it what I want to say?
Yes, sir. Sir, it should come under dead load only, na?
Yes, I am adding this dead load. You can see this.
Yes, 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 sir.
So similar way, we have to add the live load also. Okay. So what I will do, I don't want to open this lounder wall because this bridge is going to rest on the main wall, not on the lounder. Select inverse, I think plate or nodes, plate. Okay. Go to the top view, select this load, go select node cursor, select only top nodes. apply. And on the same way, just open the cap plate, highlight. So now here you can choose any two loads, maybe this one and this one. Okay. Applied. So now we have taken care of the self-head of the bridge. On the similar basis, if our live load is a 3 kilonewton, so we need to calculate live load, additional live load on the wall. So let's start calculation. Span is 6.6, our span.
Diameter by 2.
3 kilonewton. Actually, on the walkway, we can consider 1 kilonewton also, but okay, because it's a walkway. It's not like a living room or kitchen, because it's a very limited space and once a while it will be loaded fully. But ठीक है, कोई बात नहीं. Can you calculate the reaction?
9.9.
6.6 into 3 divided by 2,
9.9.
9.9. Perfect. So reaction is 9.9. So same way we have 3 nodes per meter. Okay. So again divided by 3, 3.3.
3.3.
So go to your front view, select I'm just open this one. I'm going to add additional nodal loads for live load minus 3.3. Okay. Now we need to add this. Hide this for a time being. Again, I don't want to see this lounder wall. Go to front view, select top row, assign to select. Okay. Now go to your groups, just open the cap. Select any two loads. Live load done. Okay. Now water load. I will start. It is okay. All good till now. Dead load, live load, how we have calculated and applied.
सर ऑन जो बीच का जो स्लैब्स के ऊपर हमने जो रिएक्शन अभी दी है वो 9.9/3, तो वहाँ 3 क्यों होना चाहिए सर?
कहाँ पे?
अभी इंटरनल जो स्लैब है उसके ऊपर अभी वो नोड के ऊपर हाँ 9.9/3 जो किया हमने.
हाँ, तो यहाँ पे भी हम एक कर सकते हैं, लेकिन सेम थिंग कि अगर यहाँ पे अगर रोटेट होता है तो फॉर सेफर साइड हमने उसको ऐड किया 2 नोड्स, क्योंकि यहाँ पे देखा जाए ना तो स्पेसिंग बिटवीन द नोड्स आर वेरी क्लोज एज कंपेयर टू दिस. So we have to just again distribute it at very fine locations. So just to avoid that, because the space is very less. So if we can just consider put this 9 kilonewton or maybe 3.3, so that can be take care of that. Or better way, you can directly consider as a 3 kilonewton plate load and just apply to here also. Uniform pressure. That can be also fine.
Okay, sir.
Okay. Now we will apply the fluid load. So first, self weight of the water. Height of the wall is 4.1. So self weight of the water directly will be 41. Plate weight minus 41 GY. How to apply? Just go to our groups, water pressure, water load. You can see I have just selected internal base plate assigned to selected plates. Okay. Now I want to add the hydrostatic pressure to the wall. For that, what I need to do, I will just open the wall, highlight. I want to see the axis. Let's say this one. Control T. Okay. So Z, local Z is outside of the plate. So means our value will be positive. Okay, no problem. Just keep all walls open. Go to the plate loads, hydrostatic, select plate, all plates. Done. Y, local Z, okay. W1, that is a 41, 0, add. Can you see? Triangular pressure is applied to the from the internal side. Now add Launder water pressure on the Launder channel or Launder slab. Just keep open Launder slab. Depth of the Launder slab is 8.2 something. As per the drawing, it is 8 meter. Okay. So I am again staying in that same load case. Add plate load. What will be the water pressure? 0.8 into 10. 0.8 into 10 means 8 minus 8 global Y. Okay, now self weight of the water is now applied on the Launder slab. Next, I want to add triangular load on the Launder wall. So for that, I just keep open this Launder wall. I want to see its orientation, local axis. It should be same as the previous one, but just I want to make sure. New view, I can create this view. Same, Z is outside. Add, save.
सर
Plate loads. Yes.
सर डाउट था, जो लास्ट टाइम का जो होमवर्क हमने लिया था, जो प्रोजेक्ट किया था, उसमें स्लैब के ऊपर हाइड्रोस्टैटिक प्रेशर डाला था क्या हमने सर?
रेक्टेंगुलर टैंक में
यस सर,
डाला होगा।
डाला था सर।
क्योंकि आइडियली होना चाहिए, अदरवाइज I don't remember, but it should be there.
Okay.
क्योंकि
So gamma
practically
into
तो
H, it should be there, gamma into H.
yes, height into density of water.
Yes.
That will be uniformly. It's not like a triangular. It will be uniformly pressure. So now yes, so we are applying load on the wall. So select, open your group Launder wall, highlight, select, done. interpolate on y local z. Now what will be there? 0.8 into 10, 8, 0, add. Done. Can you see this? Triangular pressure is acting on the Launder wall. So this way we are done with the hydrostatic forces. Now next is soil load. Self weight of the soil on the toe. So that is self weight is 20 into what is the height?
0.5.
4.1.
Oh, sorry, 4.1 is
82 kilonewton. Plate load minus 82. Where it will be act on toe. Select only toe plates, highlight, assign, done. Now add lateral soil pressure. What will be that? Ka 0.5 into 4.1 into 20. So same 41 kilonewton triangular pressure. Okay. So now we need to be very careful, because if you see, if I go back to drawing, so up to this height you have to apply the soil, and after that up to this you have to apply soil load. You cannot directly apply soil load to this wall, because this portion is covered by the Launder slab. Okay, so what we need to do, so we need to minus top plate which is covered Launder walls. Okay, how much that? 0.82. So 4.1 minus 0.82, that is our height, into 0.5 into 20, 32.8. Okay, understand what I want to say? Clear है?
सो लॉन्डर का हाइट घटा दिया अपन, टोटल हाइट टैंक का जो था
करेक्ट
उसमें से।
करेक्ट। मैंने कैसा कि मैंने क्या किया,
4.1 माइनस कर दिए 8.82।
अभी मैंने यहाँ तक कैलकुलेट किया, so मैं अभी क्या करूंगा, यहाँ पे ऐसा सॉइल लोड लगा दूंगा। करेक्ट?
यस सर।
एक्चुअली ये यहाँ पे जीरो नहीं होगा, यहाँ पे तो कुछ तो वैल्यू होगी। यहाँ पे जो वैल्यू होगी, सपोज दिस इज एक्स वैल्यू, so same x value will be here also. Correct?
यस सर।
This is not zero. Correct? Ideally ये ऐसा होना चाहिए ना, अगर if I draw the free body diagram at 0.8, I should get some values. Okay, but just for our convenience, what we are just breaking, this is first triangle and another, this is the second. This is not triangle, but this value will be same. Okay,
यस सर।
so count for this 8 meter, what is the x value? 0.82 or maybe 0.8, 0.82. Let's say 0.82 into 0.5, that is Ka into 20. So 8.2. The pressure will be 8.2. So same thing will be here, 0.8.2. And at bottom, what will be there? Total height is a 4.1. 4.1 into 4.1 into 0.5 into 20. So again 41.
सो ये 0.5 बेस का लिया?
नहीं नहीं, के और के
अच्छा,
ओ।
के, ओके ओके सर, अंडरस्टूड। एज्यूम किया जाता।
हाँ हाँ, वो coefficient of internal friction
यस सर, यस
of
सर।
soil particles. Okay, so what we will do, we will just apply load on the Launder first. Save. Launder wall. Okay. I don't want this. Okay. Add plate loads, hydrostatic, select, done. W1, what is the value? 8.2. W2 is 0, Y, Z. You can see I did one mistake. It should be minus 8.2 because now it is against local Z. Na?
Yes, sir.
How to delete that? Save this. Go to your style editor. Go to that your load, soil load. You have to search here. Fluid load. Shit. Because we have number of plates, that's why it is repeating. Yes, so now you can select up to this, because don't delete this, because this represent for sulfate of the soil on the top plate, that is minus 82. So except that, you can delete everything. Save this. I will see what is there after some time. Okay. Now uplift. No, soil load, plate load, hydrostatic, select, go to your groups, Launder wall, highlight, done. It's minus 8.20, that is correct. Add. Okay, now select only walls. So we will just finish this loading, and in next session we will just finish the analysis part. Now select
0.62.
0.82. Select only these walls. Okay, because above that there is a Launder wall.
Okay, sir.
Now stay in this load, add, plate load, hydrostatic, select, Done. Now W1 will be minus 41 and W2 will be minus 8.2. Y, Z. Got it? What I want to say? Why I have provided W2 as minus 8.2? Because this is at the bottom of the Launder channel. We are talking about this. We have some values there. Okay, that's why. Add. It will take some time. अरे hang होऊ नको.
Sir,
Mhm.
in fluid load from bottom 3.28 to up to top, we need to assign inner periphery of Launder wall hydrostatic load.
Yes. Can you please repeat your question?
We have applied the fluid load for outer periphery of Launder wall.
Yes, for this wall.
But also for inner periphery also we need to apply hydrostatic.
No, because what happened? See, so up to this, both level will be same. Correct.
Maybe
Yes.
If you go up to this, so what happens? So same equal opposite load will be there. Okay.
Yes.
So there is no point. It will be same equal and opposite. And if it is empty, means there is no water at here also,
Yes,
because
right.
water will be passed through this location. Then only water will be there. If there is a tank is empty, obviously there will not be any water in Launder slab or Launder channel.
Okay.
Okay.
Okay, sir.
Now yes, so this load is now applied. Only load is remaining, that is uplift. Our total wall tank height is 4.1 plus 0.5 is the base slab thickness. The total wall height from total water height is 4.6 into 10, that is 46 kilonewton per meter square. So save, uplift, add, floor load, sorry, plate load, full plate load. Now it is acting upward, so I'm not adding as a my negative, so it will be positive. 46 global Y, add, assign to entire base slab, highlight, assign to selected plates. Okay, save. Done. That this way we have applied all the loads. Okay, I think one load is there remaining, that is a soil surcharge. Correct. So I will add that quickly. Plate load. So 1 meter surcharge means 10 will be against local Z. So that's why I'm just adding minus 10. I have selected all the Launder wall. Surcharge applied to Launder wall. I will select all the walls. except top 0.8 meter or point. So except this. I have to apply surcharge. Done. Save. So this way we have done all the loadings which is applicable on the circular tank, whether it is clarifier or clear well. Okay. So in next session, what we will do, we will finish analysis, extraction of the results, and hopefully we can finish everything related to the circular tank in the next session.
सर वो रेक्टेंगुलर का एग्जांपल ओपन कर सकते हैं सर, जिसमें मैं जो क्वेरी बोल रहा था कि हाइड्रोस्टैटिक प्रेशर ऑन बॉटम स्लैब को अप्लाई किया था कि नहीं सर?
अगर नहीं किया तो we can apply that. If I miss, so same thing like
टो
just.
के लिए भी करना पड़ेगा सॉइल प्रेशर, टो के लिए भी?
Yes, करना पड़ेगा definitely.
क्योंकि रिकॉर्डिंग में मुझे नहीं मिला था सर.
नहीं तो हो सकता है मैंने मिस किया है, तो yes we can add that.
Okay sir, okay sir. So from
Just
this
create.
example we can.
Yes, just go to the fluid load.
Yes.
Add. Go to the plate load, full pressure, and I think water height is a 5 meter, correct?
Yes.
So only 50 kilonewton, minus 50 kilonewton you can apply to the water load plate.
Yes.
And same thing you can apply the soil load on the toe.
Yes sir, yes sir.
Ideally there will be, it should be, and
Sir,
we have to consider.
दो लोड अप्लाई किए थे कि -50 और 55, दो लोड अप्लाई किए थे हाइड्रोस्टैटिक में?
नहीं हुए थे सर, रिकॉर्डिंग में नहीं सर.
नहीं है क्या? ठीक है, मैंने मिस किया होगा. So good to you have noticed and just bring it to me. So yes, so we have to consider that definitely.
Yes sir, yes sir.
Okay, I think
Done.
it's too late. Maybe we will stop here and we will continue in next session.
Okay sir, okay sir. Thank you sir.
Yes, thank you. Good night.
Thank you, sir. Good night.
गुड नाइट सर.